Hello, this is a Comsol demonstration for a project working with ASML. First, when you open Comsol, you click on Model Wizard, 3D, Heat Transfer, Conjugate Heat Transfer, Laminar Flow, click Add, and then click Study, click Stationary, click Done. So here we start off with a blank slate. First thing we want to do is we actually want to set the parameters that we will be using. And in this case, one of the more important parameters is the flow of the water in the channels. So we're going to call this U1, and we will set the speed at 50 millimeters per second. Now, if we put the units in square brackets, as over here, then after you click anywhere else, it will show out the value and convert it to meters per second. And so that's the first step. And then after that, what we want to do is we want to go to geometry. The first thing we want to do is we want to create the block that we want to use. So we're gonna go to geometry over here, click block, and what you'll have is you'll see all these settings over here. We want a solid block, and the dimensions that we want to have it is 150 millimeters, which is 0.15 meters, and depth is 0.15 meter as well, and the height is 0.01 meters, which is 10 millimeters. And then there's also other things you can change, like the position, the angle, and things like that. But for now, we'll leave it as default. And what you could do is you could click build selected, and it will show up the block built for us. So in this case, yeah, this is how it looks like. And the second thing we want to do is we want to add channels. So what we're gonna do is we're actually gonna make one single channel first, and then we're gonna use an array to kind of duplicate them together. So we'll click on a block again, and this time it will show up as block 2. We're gonna set the dimensions. The width of this block will be 1 millimeter, so it will be 0.001 meter. The depth of this block will be 150 millimeters, so 0.15, and the height of this block will be actually half a millimeter, which is 0.0005. And for the position of these channels, in this case, we're going to set it at 15 millimeters from the x-axis. So from one side of the surface, we're going to set it as 15 millimeters. And from the z-axis, which is from the top of the surface, we're going to set it 2 millimeters downwards. And so the rest could be left at the default. And what we're going to do is we're going to click build selected again, and you can see that this small block actually popped up. And so that is one channel that is done. So we'll go to transforms. Underneath transform, there's array. And what we want to do is we actually want to change the array size first. Instead of 3-dimensional array, we want to make it a linear array. We want to have 40 channels side by side. And for input objects, we want to actually hover over that channel that where we just created and click on it. So this would be our input. And then the next thing we need to do is we need to set a displacement for these 40 channels that we're creating. So we want it to go along the x-axis over here and duplicate itself with a 3 millimeter displacement in between. So what we'll do is we'll put 0.003 meters and then click build selected as well. And you can see that the 40 channels have now been built as well. The array section is scroll down to cumulative selection, click create new, and type channels. We're going to label it channels as we're going to merge all 40 of these channels together. Yeah. And so after that, you can see that you have the channels labeled in cumulative selections on the side over here. The next thing we're going to do is we're going to actually select the materials. So we're going to go up here to the materials tab, click on add material. What we're going to do is we're going to look for fused silica. So we would type fused silica, and then and that's because this whole material is made from fused silica. And so what we're going to do is we're going to pick the there's a lot of fused silica choices. So what we're actually going to do is we're going to pick the fused silica that has the average properties. Um, so if we look down the list, there's Corning 7940 fused silica solid average. We will click add to component, and it's the default, it would choose all the domains, but for now we're only interested in having the first domain, which is actually the block, being the actual actually made of fused silica, and the other 40 domains we want it to be water instead. So the next thing we're going to do is we're going to look up water. Alright, and we're gonna pick H2O, water as a liquid, click add to component, um, and so in geometric entity level it's domain, and then under the selection, what we're actually gonna do is we're gonna click channels, and here's where it comes in handy, the water settings. We're gonna change the selection to channels. And what it will do is it will actually add all the 40 channels that we just created just now. And in this case, you don't have to select it one by one. And now that we've set all the materials together, what we're going to do is we're going to start selecting and changing some initial property values inside our block and also our channels. We're going to start changing the properties in the heat transfer in solids and fluids. So first we're going to go into the fluid section actually, and we're going to pick the channels selection as the fluids. What this does is that it assigns the channels to be a fluid item, and then the next thing we'll do, we'll go to initial values, that is set as room temperature, which is what we want. Thermal insulation, we're going to leave it as the default as well. And then what we're going to do is actually we're going to go to physics, and what we want to do is we want to add an inflow actually. So we're going to go to boundaries, click inflow, and from the inflow, we want to actually zoom in and kind of select one side as the inflow. So we would actually, in this case, have to click every single surface of the 40 channels. Have not found a way to kind of go about that. But as we go along and select each channel, we'll set that as the inflow. And then now that that's done, we also want to make sure that the upstream temperature is also room temperature. And then what we're going to do is we're going to add another boundary called the outflow this time. And what we want to do this time is we want to actually move the cursor, move the cat belt around to the other side, and then start selecting the channels as well on the other side. So now that we've selected all the outflow surfaces of the channels, we're going to add one more boundary heat, where we will choose a boundary heat source. And this is part of the problem that we were given by ASML. We would have a heat source that is continuously generated on the top of the surface. So what we'll do is we'll actually pick the surface that is closer to where the channels are. So that'll be this bottom surface over here, and then we're gonna change the heat source to be user-defined 100 watts per meter squared. Okay. And then for laminar flow, under fluid properties, we're gonna make the volume reference temperature as room temperature. Initial values, we'll leave it as it is, and what we'll do is we'll actually also do the same thing where we're at an inlet. So we'll go to boundaries, laminar flow, click inlet. What we're gonna do for the laminar flow inlet is we're gonna set it to be the same as the inflow. So what we can do is we can go to inflow, click on copy selection, and this will copy all the surfaces that we selected just now. Go to inlet 1 under laminar flow again, click paste selection, and then paste the value, the 40 surfaces. And then we do the same thing for outlet. So we go to boundaries, click outlet, laminar flow, go to outflow 1, click copy selection, go to outlet 1, and then click paste selection, and Ctrl V to paste your selection in there. And then for inlet, we have to actually change the velocity field. So this is where U1 comes in from the parameters, which is 50 millimeters per second, as we said just now. And then for the outlet, what we're going to do is we're going to leave it as it is. And then this should be all, actually. So the last thing we're going to do is we're going to go to mesh, and we're going to click on build all. So what this does is that it would mesh the entire block into chunks that are really small, like 0.5 millimeter or 1 millimeter ish, depending on the size of the mesh that is chosen. And here we chose a normal element size. And then after we mesh it, we just need to click on study and click on compute the study, and that will take a while. It'll take like an hour or so, but after that we should be able to see the results. So after meshing is done, it will look something like this. All these are basically the elements that is broken down into, and then we go to study and click on compute, and then once we click on compute, it's going to start running, and after that we'll see a result like this. And so what this shows is that we can actually kind of see that on top of the channels we can see the distribution of temperature. So you can and what you can do is you can actually click on any single point and it will tell you the temperature value. So this is 300 Kelvin at this point, and then on the lighter color it's 302.7 based on the scale over here. So we can tell that essentially for this run, there is a distribution of about 3 degrees Celsius from on the surface.